Hello everyone, welcome to this session. Our chapter is Newton's law of motion. So in a previous session we discussed about the second Newton's law of motion, and we also discussed the concept of this linear momentum. So in this session we will see the principle of conservation of linear momentum. Uh, but first we have to discuss the difference between elastic and the inelastic collisions. So these are just two types of collisions, whereby collision, this is just the colliding of or just the interaction of two bodies when they move against each other, you can say. So that's the meaning of collision. Now in terms of elastic collision, this is just the type of collision whereby each body moves with separate velocities after collision. So this is the first kind of collision, whereby after the collision the bodies involved in the collision, they move at separate velocities. In this kind of collision, or in this type of collision, both the energy and the momentum are conserved. So later on we'll discuss about this principle of conservation of linear momentum is based on this elastic collision. So because in this kind of collision, both energy and momentum are conserved. So that's how it is. And here is the illustration. You're using this for example, these two bodies before collision, they are moving in these kinds of direction. Now after collision, they move apart, but they move at separate velocities. But in that case, they move and both energy and the momentum are conserved. So that's elastic collision. Now, in terms of inelastic collision, this is just type of collision whereby all the bodies, they move with the same velocity after collision. So you can differentiate these two by in terms of velocities observed after the collision. Here the velocity is the same, but in terms of the elastic collision, the velocity becomes different. So that's how you can tell the difference between these two. Now the velocity that is obtained, that is the same throughout the bodies, is known as the common velocity. And in this kind of collision, energy is not conserved, only momentum is conserved. So you can see the difference in elastic, both energy and momentum are both conserved, but in terms of inelastic, you notice only the momentum is conserved. This energy is not conserved. So here is the bodies illustrating or showing this kind of collision. Before collision, they were moving in these directions and maybe at some kind of forces. Now after collision, they move with the same velocity, showing they are moving in this kind of direction. So that is what we call the inelastic collision. Now let's see impulse. Impulse, what's the meaning? It's the change of momentum, which is given as the product of force and time taken to change the momentum. So you can simply say impulse is just the product of force and time. So impulse is equal to force times time. And here the mathematical expression of this: impulse equals to force times time. Impulse is equal to F times T, I is equal to F times T. Now from the second Newton's law of motion, if you say that force is equal to mass, you multiply by the change in velocity. So mass times the final velocity minus mass times the initial velocity over time. If we multiply F with T, making equal to mass times final minus minus mass times initial. So F times T, that is simply the impulse. So impulse is equal to mass times final velocity minus mass times initial velocity. So that's how you can relate the impulse with the second Newton's law of motion. Therefore, we can say that impulse is just the change in momentum of the body, which is acted by a given force. Now, the forces which act over short time intervals are what we call the impulse forces. So we can simply say the impulse forces are just those kind of forces that they act at a very short given time or just period of various intervals. So that we call the impulse forces. Now, let's see the principle of conservation of linear momentum. The principle of conservation of linear momentum is just that when two or more bodies acts upon another, just see without external forces acting on them, the total momentum before collision is equal to the total momentum after collision. So you can simply say that this kind of principle, it it bases itself in terms of the collision. That's why we discussed the collisions, the inelastic and the elastic. In terms of elastic and the inelastic, we discussed the what is being conserved. The momentum is conserved in both, but in terms of energy is conserved only in elastic, but not in inelastic. So this principle is basically when the bodies they collide. So the total momentum before collision is just equal to the total momentum after collision. Now consider bodies A and B of mass ma and mb at initial velocities a and ub respectively in motion before collision. Now considering this, so before collision, let's see, as you can see here, mass A moving in this direction at UA, and mass B moving in this direction at UB. Now that is before collision. So the momentum of body A before collision will just be equal to MA times UA, and the momentum of body B before collision MB times UB. Now the total momentum before collision will be just equal to MA UA plus CMBUB. So that is before collision. Now, after collision, the two bodies moved with the velocities VA and VB in opposite directions to each other will be shown as below. As you can see now, after collision, MA mass A will move in this direction at given velocity VA, and the mass B will move in this direction at velocity VB. Now, momentum of body A after collision will be equal to MA VA, momentum of body B after collision MB VB. Now, the total momentum after collision will be MA VA plus MB VB. Now, from there, you can see that during the collision, there are large changes of forces within a very short time, what we call the impulses, as we've discussed the impulses. The impulse, what does it mean, the impulse? Now, impulse due to body A will be equal to just MAVA minus MAUA. Now, impulse due to body B will be equal to IB is equal to mass B VB minus mass BUB. So that you can get the impulses of both bodies. Now, since there are no external forces acting on the system, as we've talked about in this principle, so impulse due to body A will be just be equal to impulse to body B. So IA is equal to IB. So MAVA minus MAUA is equal to MBVB minus MBUB. So finally, you can say that the same goes to B equal to MAUA plus MBUB equals to MAVA plus MBVB. So that is what we call the principle of linear momentum. So that's clear, everyone. Thank you for listening in this session. We've talked about collision, we said the meaning of collision, the types of collision, elastic and the inelastic collisions. Then we've discussed the impulse. Then we've later on discussed this principle of conservation of linear momentum, how it occurs in correlation to what we've discussed, the elastic, the collision of both of them, elastic and inelastic, then also in accordance to the impulse. So that's clear, and thank you.